Hey everybody, this is Mr. Grabo. We are starting our new unit here. It's called Systems, Spheres, and Cycles. And we're covering learning targets 1 and 2 today. So we're going to start off as the Earth as a system. Now, to define a system is part of the universe that can be studied separately. Part of the universe that can be studied separately. Scientists sometimes study individual parts of the Earth, such as maybe how do mountains form. Scientists might study classifications of life forms, or maybe how do tornadoes form. But the best way to understand the Earth is not to understand the parts by themselves or in isolation, but as one larger system. How do they work together? So let's think of some other systems that we know of. And on the right-hand side of your paper, you can write some examples. But some other systems that I was thinking of are like river systems. In the picture here, you can see this is the Mississippi River system, and all these smaller rivers and streams come together into one larger stream, and it forms a big system. They all work together for kind of a common purpose. Ecosystems, all the living parts of like a forest, all the different pieces of that ecosystem working together for those plants and animals to thrive. A car, lots of parts in a car that work together to make it work. There's the steering system and the cooling system, the radio system, the steering system, all those parts and those systems working together as kind of a larger part. Computer system, you got your computer chips, you got your keys and your screen, all those things working together as a bigger system. What we want to focus on today, as far as systems goes, is open and closed systems. When we're talking about an open versus a closed system, we want to look at two things. We want to look at matter and energy. If you remember what matter is anything that has mass, and just any kind of thing that has mass and takes up space is matter. So looking at a closed system, as far as matter goes, matter does not enter or leave a closed system. It is closed off, so matter cannot come and go through a closed system. Okay, notice the bold words. You might want to highlight or underline those bold words in your notes. Now, what does energy do in a closed system? The energy in a closed system, some energy is able to enter and leave. Now, when I think of energy, I usually think of heat. Heat is just one form of energy, but it helps me to kind of visualize energy and what we're talking about. So some energy is able to enter and leave a closed system. Now, in an open system, matter can enter and leave. Matter can come and go in an open system. The energy in an open system, energy in an open system can enter and leave freely. It can come and go very easily. So let's predict. What type of system would the Earth be? What does the energy do in the Earth system? What does matter do in an Earth system? Does energy come and go? Does matter come and go in the Earth? So let's think about this a little bit. What kind of system is the Earth? Let's think about the energy. The energy from the sun is absorbed by the Earth's atmosphere and surface during the day. So the sunlight heats us up, keeps the Earth nice and warm. But then energy is also lost back into space at night as heat or thermal energy. So some of the energy enters, some of the energy can leave. Now let's look at the matter. What does matter do in the Earth system? Well, the matter on the Earth is the same matter that was here when the Earth was formed. For example, let's think about maybe water. The amount of water that's on the Earth right now is the same amount of water that was on the Earth when it was formed. So the water doesn't enter and leave the Earth. It stays here. It's just right here. Okay, you could think of the same thing as iron, like the amount of iron that's on the Earth. We have no more iron on the Earth now than we did back when the Earth was formed. Okay, matter changes form, but the total amount of matter remains the same. So matter can change form, but the total amount stays the same. So like I was saying, with water, water can change form. It can be ice, it can be water, it can be water vapor up in the clouds, but it stays the same. That same amount is here. So we would refer to the Earth as a closed system. Earth would be a closed system. Okay, now you might be saying to yourself, well, wait a second, aren't there some examples of matter in the Earth that's leaving the Earth, like maybe an astronaut? Yeah, there's a couple examples. Let's look on the right side of our paper. Are there examples when Earth does not act as a closed system? Sure, there's a couple examples. A meteorite hitting the Earth. That meteorite wasn't here before, so yeah, there is a couple examples. Also, the upper atmosphere has got hydrogen. Hydrogen is very, very light, and so some of that hydrogen can actually escape out into space. Space exploration, satellites, we've launched hundreds of satellites out into space. We've sent things to Mars, and so there are some examples of where the Earth is not closed, okay? But the vast majority of, all the stuff inside the Earth, for the larger picture here, it's a closed system. There are a couple of small examples, but the Earth as a whole is a closed system. Okay, and so when we think about all our resources here on Earth, we got to conserve and protect our natural resources because we only have what is here on our Earth. We can't create any more than what we have to start with. So we have to protect our things like water and our natural resources. Okay, one way we can think of a system, I often think of it as like a jar. Either the lid is on or the lid is off. Okay, here's an example of something called sun tea. It's made with bags of tea in water, and you put it in a closed jar, and you let it heat up in the sun. So how is this similar to the Earth as a closed system? Well, let's first think about the matter. Can matter enter or leave a closed jar? No. Can energy enter or leave this closed jar? Well, sure, some energy can enter it. You got the heat from the sun, the sunlight, heating up the liquid inside the jar, and some of that heat could also escape. And so in this situation, yeah, this would be a closed system. If you took the top off, this would be an open system because the matter could now enter and leave. So let's brainstorm a little bit on the right side of your paper. Let's think of some examples of an open and a closed system on the right side of your paper. See if you can come up with an example or two. You might want to think about maybe the systems in your body, a circulatory system, all the veins and capillaries where the blood runs inside of your body. Is that an open system or a closed system? Maybe your digestive system. When you eat things and it goes through your body, is that an open system or a closed system? Okay, let's move on to the next part, which is about the Earth's spheres. Everything in the Earth's systems can be placed into one of four major subsystems. The first one is called the hydrosphere. Hydro refers to water, and so the hydrosphere refers to all the water on Earth, all the water in all its phases. So that would be the definition. When we talk about the phases of water, we're talking about is it solid, liquid, or gas. So the key word is water. Keyword is water. And I'm sure you can think of plenty of examples of water on the Earth. Rain, oceans, a glass of water. All those would be considered part of the hydrosphere. Now, there's kind of a smaller subsystem, I guess, of the hydrosphere, which is what we would call the cryosphere. Cryosphere refers to the ice. Okay, so yes, this is part of the hydrosphere, but it's a specific part of the hydrosphere that's of great concern. We often talk about the polar ice caps that are melting. And so you'll hear us referring to what's called the cryosphere in the coming lessons here when we start talking about climate and climate change. So some examples of this would be like, the ice shelf in Greenland, or maybe the polar ice caps, glaciers, things like that. Okay, next is the geosphere. The geosphere, or lithosphere, litho means rock, geo means earth. So what we're referring to here is all the rock that's on the Earth. So all the rocks, the minerals, soils, either on the Earth's surface, in the ocean basins, like the floor of the ocean, or even on the inside of the Earth. We know that the inside of the Earth is like magma, and there's rock that's on the inside of the Earth in a different form as well. So this picture here is a picture of what the Earth looks like with no water. So we're just referring to all those rocks and minerals that make up the Earth. All are part of the geosphere. So the key word here is rock, and I'm sure you can come up with a couple of examples of things that are made of rock. Mountains, minerals, maybe like iron or any kind of other type of mineral you can think of, talc, ocean floors, all examples. The atmosphere. The atmosphere definition would be the blanket of gases that surrounds the entire Earth and extends to the edge of space. Here in the picture you can see the thin atmosphere that surrounds our Earth. So all the gases that make up the atmosphere, not just oxygen, but there's nitrogen and carbon dioxide and other things. The key word here is air. So any gas could be an example. Carbon dioxide, nitrogen, oxygen. The biosphere. The biosphere refers to all the living things that are on the Earth. Bio means life. Like the study of biology is the study of life. So this includes any living thing that is on the Earth. Key word here would be life. So think of a couple examples of living things for your examples. Okay, now to kind of summarize this, let's think about how does all this interact with each other? So if we take an example like an erupting volcano, a volcano erupts and it releases lava and volcanic bombs, which are like large rocks that it shoots out of the volcano. Those are part of the geosphere. Okay? And gases and ash go off into the air, putting that out into the atmosphere. Animals and plants get burned up. Those are part of the biosphere. Ash flows can fill up the river. That would affect the hydrosphere. And so all these different spheres of the earth can be affected by this one event. And so we got to understand how the earth works together as a whole, and how do these little pieces kind of go together in this big puzzle of how the earth works as a system. So if you remember back towards the beginning, I talked about how the best way to understand the earth is not to study the parts, but understand it as an entire system. And when we look at these spheres, we can see how these spheres interact with each other. Okay, now there's a little bit of practice going over some of the key words like hydrosphere and biosphere, and also a couple of problems about open and closed systems. So use your notes to help you out and answer those questions, and then submit this to the assignment. And as always, ask your teacher for help if you need it. Okay, thanks for listening. See you later.